Hi there, this is the second session on the new SoundPLAN version 8 geodatabase editor. In terms of the new sound particle model, a new editor was created. I had a general introduction last week, and I just want to continue on the same project, make changes and add additional objects into the room. So for right now, I'm just opening up the geodatabase. And here again, the situation manager, I created a new situation and I made a copy of the last geo file. That was this one here. And yeah, so that will be 002. So this one I copied and I created a new geo file with the same information, but we will add additional sources and an enclosure inside that room. So let me open up that that situation. So here again we have our building, and so here's our building that as far as we had it last week. So we had a control room right here. We had 4 sources here in the open, 4 sources in this area, in this machine room area. And then if I open that up here, so here we have the control room, here's the machine room, and I changed the openings here. I just moved them up a little bit right here, so you can select them and then move them wherever you would like to move them. And so at this point, I want to go back and add a couple of machines or cubic objects into the into this room, and this could be larger equipment that of course has some effect in terms of structural shielding and then also reflection, and then of course if it's a source also energy or sound energy that is radiated into the room. So this could be from a pump room, a pump electric motor inside an enclosure. It could be also a power plant that is inside a power plant building. So with HRSG, with a genset or turbine generator, air intakes, and so forth. So there's a lot of applications here that this really opens up the modeling for that. So here up here we have the object machine, and again machine could be any object that has rectangular bases with a certain height to it. And so I'll start with a very simple one, just a rectangular object. I'll zoom in here a little bit. All right. And so I'll make it about 1.5 meters wide and about 2.5 meters long. All right. So select it, and so here we see the dx and dy, so 1.5 by 3 meters. All right. And we can define it with the full height of the building. Of course, that's not sensible for this. This will be an electric motor. We'll make it 2.8 meters in height. And we can put it with a distance to the ground floor. If we have no distance, it puts it right on it. So I'll put in like a 6-inch spacing to the floor, and I'll click OK. Check it, and at this point the program automatically created an object, and this is called machine, and so here we'll just call it electric motor, and I'll give it a number 100, and then with that all of the other sides, so we have 6 sides that will be defined as sources, area sources. So we have a top, the 4 walls, and a bottom. Now at this point these the area sources are not radiating, so here if we click on this one, so we have to enable each of the sides or the surfaces to be a source. So what I'll do is I'll do the top and the 4 sides. The bottom I'll ignore at this point. So I highlight all of those and set them up as enable the source. And here, just the same as with other source definition, I'll define, select the definition out of the library. I use the library definition, which is 85 dB per square meter sound intensity. So I make it uniform in all direction. And then also in terms of material, I make the surfaces all relatively hard. So I have this absorption spectrum for concrete. We can apply that for this. And then also maybe for the bottom here. Now the bottom here is basically not defined as a source, and that is fine. All right. So with that, we can add a pump in front of it. So I'll just add another source here. And this source we make 1 meter wide and maybe 2 meters long. All right. And this whole thing is maybe 1.2 meters. So that's about 4 feet high. And and again, here the same thing. So here this is our pump. And again, we can do the same thing as with the other one. We define these as sources. We have here our sound power level. And we have the concrete as a reflective surface definition. All right. So now we have 2 sources here. So if we had like a pump row, we can of course select these 2 sources, and by highlighting both of them up. So I click them with the shift button here, and then with that both of them are selected. And then here we can again do a duplicate, and we make a duplicate 2 times, and I'll make it with a spacing of about 1.5 meters, so make it 8 feet, so 2.4 meters. And so here we have now our duplicates here. So again, here we can change the source names. And with that, we have them all defined. So this would be pump 100. This is pump 200. And this is pump 300. All right. So these are all defined the same way. So they all have the same source levels and so on. So if we need to make changes, we can do that easily. Now at this point, of course, these are fairly loud, so I just want to show you kind of like how we can add an enclosure within the building. So the way to do that is we defined a vertical object over these 3 pumps and electric motors. So I'll select this one and I'll start here, move it over this area, and the whole thing will be 4.5 meter in height. We'll define it as a body, and so here we have it. So this will be our enclosure. 100 to 300, and again here we can define the different walls and the roof, and we'll define it with corrugated steel, so transmission loss. We can make it all reflective, or if we want to make the inside absorptive, we can put some absorption on the inside. That's the inside walls and the roof of the enclosure. And this would be it. So let me save this, and let me open that up one more time just to show you a few things in terms of the view control. So right now we don't see anything here because the view is basically from the outside. So let me zoom in a little bit. So here we have 2 enclosures, and actually we probably should put in a door into this one enclosure. So let me open up. This is the wall, so we'll want to put a door into that wall. So let me select this as a reference object. We'll put in a wall, a door into the wall right here, and this will be the enclosure door. And worst case, someone leaves the door open, so I'll leave it open. And so now we can actually look into that enclosure here. All right. So let me go back. So here we have our enclosure within the building. Here is we have our control room. And in case we want to actually look into these control room into the enclosure, here we can change the way the objects are shown by clicking on this triangle here. We can see basically all objects, or objects only that are smaller than let's say 3.5 meters, and then we can basically look into the enclosure here. All right. Okay. So let me finish this here. I'll save this, save the situation, and I want to go into the calculation. So here we have the calculation, and let me change a few things here. I'll delete the previous results that I got here. I change the tolerance 2.5, and the grid spacing will make it a little bit finer. Let's try it with 1 meter, and yep, and we start the calculation here. So here in the graphics, we can follow the calculation. So it's creating the grid receivers right now. So here we have our grid receivers. Again, we have this enclosure around these 4 electric motors and pumps. And so now it's actually starting on launching the sound particle modeling. So from every source, it's emitting particles in all directions. And then, of course, with that, we have different areas or different spaces. We have this big open space, we have the control room, and then we also have this machine room here on the right-hand side. And then, of course, with each of them, it has to reflect off surfaces. It also has to transmit through surfaces if we have walls that have a transmission loss defined. And then also if there are openings, of course, as it goes through the openings, there is some scattering and shielding that is kind of considered in the model. So this should be soon coming out with our first results. I think the very first set is about 80 particles per source. All right, so here we have our first answer or predictions. And let me auto scale here. And yeah, this is not, let's say, not completely unexpected. Of course, we have very high noise level here in the enclosure of these electric motors and pumps. There is some noise leaking through that opening that we have in this enclosure. We have higher noise levels around these sources here and there that are in the open. And then, of course, pretty high noise levels also here in the machine room that is here on the side, which is overall relatively reflective. The lowest levels are here in the control room. The control room, again, mostly we are getting noise in here through the transmission of the walls and also the open door that we have right here. So at this point we have 80 like particles per frequency and source sent out at this point. We can kind of already see that certain areas the noise it's not kind of like it's not that likely that particles hit those areas. So these are some of these areas in the enclosure or right beyond the enclosure. There's so we'll need more modeling to get enough sufficient energy into these areas to get a better prediction here. So right now we doubled it up to 160 particles per frequency, and it's starting to kind of level out here. We can also look at the sigma. So these are the sigma levels, the uncertainty levels. Again, the uncertainties are inside the control room, relatively high. Some of these areas where the particles are not as likely to arrive. So that looks as expected. And so at this point we can just let it continue to run and till it meets the uncertainty criteria. I think the uncertainty criteria was 2.5 decibels, less than 2.5. So it has to maybe go and double, triple the number of particles to get that to that point. At this point, I want to close this here, and we'll go over some more information at the next video. Thank you, and bye for now.